My guest today is Wayne Ojala. Wayne has a degree in engineering and also runs the YouTube channel Fail Forward Research, where he documents his experiments into gravity manipulation and other bleeding edge physics concepts. It was an honor for me to be able to sit down with Wayne and actually perform an experiment with him live during the interview. If you're finding these interesting, these interviews and other videos, please consider subscribing to the channel and also check out his YouTube channel, Fail Forward Research, for all of the other experiments that he's done. And hit that like button. I will be releasing a new interview every Thursday afternoon weekly, and I welcome you to come along for that journey. So without further ado, here is my interview with Wayne Ojala.
Yeah, so my name is Wayne Ojala. I have a channel called Fail Forward Research on YouTube right now, and I just post experiments where I investigate ideas and possibilities regarding the control or modification of gravity for propulsion and for other future advances for humanity. And also I dabble in energy science research, motor generators, battery charging, and that sort of thing. So for me, these interests go way back to childhood. And in recent years, I made a decision to really just dive in to see if what could be done in these matters, particularly with gravity, because it's always been something that's bugged me. Just trying to understand what it might be, and I've been very curious about it. And over the years, I got a diploma in mechanical engineering technology in 2011. So I've worked on and off in some engineering roles. The last few years have been mainly focused on this sort of thing. I got involved with the APEC community, met Mark, so-called, several years ago online, as we were both delving into the Alciphon experiment by Fred Alciphon, who has passed away. His son David has been carrying on that legacy, that work, trying to get interest, and so that was very interesting. So yeah, dabbled with that quite a bit, and that's sort of an ongoing. I don't know if that experiment's ever going to be done, but it's something where you do it, and then you learn, and then you redo it, and then you learn some more, and so. But yeah, that's one thing. I've also dabbled in what would be called electrogravitics, which is just basically high voltage capacitors and observing their movement. I dabbled with that 10 years ago after reading about that sort of thing in Paul LaViolette's book. So yeah, I have mainly about 15 years of background in exploring these ideas. What really got me going down what you call the fringe science route would be coming across energy from the vacuum on the internet. This is going back to like 2007, 2008, and came across that, and it just really got my curiosity, because I was looking for to do something with solar energy. I was interested in that, and working with the control of heat, heating and cooling. Anyway, so came across energy from the vacuum, and then I started. That led me to Patrick Kelly's book about free energy devices, and he's sort of like, you guys are probably familiar with it. He's categorized all these different patents and stuff that have been out there for a long time. Some things suppressed, some things just forgotten. So I spent a lot of time reading that, studying that, and yeah, it sort of laid the foundation for the last number of years for me.
And you said that
So
was David Kelly. I just want to make
Patrick
sure to note
Kelly,
Patrick Kelly. Okay, cool. Yeah, I want to look into that
yeah,
myself.
it's like a PDF. He's been doing this a long time.
Okay.
He's sort of catalogs all these, writes about these different patents and inventors, and so it kind of gives you a good overview of many different innovations that have happened in the space of trying to make machines that will run themselves or provide extra energy, you know,
Right.
outside of the conventional paradigms.
Fascinating.
So
That's what this is all about. That's what got me interested in all of this as well. You have many more years than I do in the space, and so I'm really grateful to get to learn a little bit from you, and I'm sure the audience is as well. Is there anything else you wanted to say about the introduction, or do you just want to show us kind of what you put together with this experiment?
well, I mean, yeah, I can get into the experiment. It's a really simple one. Um, my introduction is pretty much just, a good overview. I could go more into depth. What I'm going to show you in this particular experiment is something I did a couple of years ago, and uh, it was sort of a development on an accidental discovery I made where, because I got this balance here, this sort of changed everything for me. A lot of my videos, I always have this balance in a lot of my videos because it actually shows very sensitive changes that you wouldn't otherwise see or detect. So it's kind of opened up a new world. Because trying to measure gravitational changes is very difficult because you need very sensitive equipment, and there's a lot of things that can go wrong, right? So,
Yeah.
but when you get experience uh, with it, and you learn sort of the nuances and things that can cause small errors and that sort of thing, um, you just learn. I've learned what to look for. But
Yeah.
anyways,
What kinds
what
of
I
things? Just out of curiosity,
that
what are the primary things that usually confound the data? What are the things that jump into the data that seem like they might be gravity manipulation, but ultimately are just from some benign cause?
well, early on, one of the weird things was I started out just using little cheap digital kitchen scales. Um, and then I was playing with high voltage. I had a Wimshurst machine, and I was charging capacitors and discharging them. And so I put these things on these little kitchen scales. And so what happens with that is when you have an electrical discharge, the thing just goes haywire
Hmm.
because the circuit inside there can't handle the noise, so it just loses itself. And
I see.
then, yeah, another one is unwanted air currents. Like you're looking for something to move, say on a pendulum, or um, you just want to be careful that you're not moving air, or
Hmm.
um, the air in the room is not moving around too much.
Right. Okay.
Um, the other one is magnetic fields. Magnetic fields from permanent magnets will change the reading on a balance just without contact. So you got to keep, if you're working with magnets and magnetic fields, you got to keep enough space between your scale.
Okay.
And also, yeah, that's pretty much, those are the main things, right? And then temperature. You want to make sure your temperature in your environment is pretty stable.
Hmm.
So those are the main
What?
ones.
Why would temperature have an impact?
Well, temperature can change. Like if you're using a digital balance with a load cell in it, if you change the temperature too much, it will create
Oh,
erroneous
okay.
readings.
So it's directly manipulating the actual
Yeah,
measurement
so you just
system.
want to keep, if you're measuring something where there's a temperature difference, like I've done a lot of this, I always try to put a layer of insulating material,
Okay.
styrofoam if I can, or whatever, just to be aware of that.
Cool. Right on. Yeah, I
The
wanted to
other one is
clarify that.
static electricity is another one too. That's a common one, right?
Ooh, okay.
Now, these kinds of things are sensitive to static electricity.
Sweet.
But yeah,
Right on.
those are the main ones. Yeah.
Cool.
So what I basically discovered was just little jars of water. I'd fill them up and then hang them on this thing, and I found that the weight would change over a period of time. It would always lose weight, and I tried a few different containers and things, and it was just sort of a puzzling thing. And I shared it with some of the other guys, and they're like, "Oh, well, it's just evaporation, or it's buoyancy, or whatever." Um, and then because I didn't have an explanation or like something that like really made sense to me at the time, I thought, okay, well, it was actually starting to drive me crazy because I'd have these bottles and containers, and I just put the lid on like super tight, and I was still getting the same objections from smart guys, right? I
Yeah.
won't mention any names. Uh, they were saying, I mean, I even put like grease in there in the lid to make a really
Seal.
great
Yeah.
seal, right? And these pop bottles, just try screw the lid on and try to get air out of it. You won't be able to. It makes a
Yeah.
really good seal.
So just to understand, you were seeing the same things that were occurring with the top on as if the top, or if the top was off. Same results, basically.
Yeah, yeah.
Okay.
I did this experiment a couple of years ago, and so I just had two identical bottles like this. One had the lid on, and one had the lid off,
Right.
and they were both filled with the same amount of water. And so what I did is I just did like I just graphed weight over time,
Yep.
and what I found was always there would be this exponential loss, and this is what I was seeing all the time, and I didn't have a good explanation for it, which made it hard to communicate this discovery with any credibility to anyone. Um, and because the magnitude of the change was so small, like we're talking, you know, tens of milligrams to hundreds of milligrams. Even if I had something, it wasn't really appealing because people are wanting to make the grab a flyer, make
Mm-hmm.
stuff jump off the table and fly into the sky, and so. But I don't know. I just took a different attitude, which was like, okay, what can I learn from this? I mean, like, how does it really work? What is the real physics going on here? And that's an important thing to ask, I think, to try to learn from it. So just before we got on this call, I just had this one. I just reset it. So I'll show you guys what this one is doing here currently. I'll try to zoom in here. Sorry if this doesn't work very well.
Oh, it's all good.
I don't know if you can see the screen here.
Yeah, it's good.
Let me change the color. Forget how to do it. Oh, there it is. These properties. Make this red
Perfect.
and make it a bit thicker. Might see that a little better.
Yeah, so your screen's actually frozen on me, but what's happening in the background is it's recording all of this, so it'll come through perfectly fine when we actually have the edit together.
Okay, good.
Yeah, so no worries. We're chilling. Good spot.
I just want you to be able to make sure you can actually see this curve.
Yeah, I'm just not able. Oh, there it goes. Yep. Okay. Perfect. I can see the graph, and we basically have a line pretty much going
See
up to
that
the right.
curve?
Yeah.
Now, there's a little bit of an issue. This thing doesn't go negative for some reason, but this is actually a negative weight.
Okay.
I'll show you the reading on the balance here. If you can see, it says
Yeah.
minus
Point four, point
0.04.
three. Yep.
So that's 40 milligrams.
0.398. Okay. Got it.
And you see the lid is on there?
Yep.
Yeah.
There it is.
Okay.
And that thing's enclosed in plastic or glass to minimize, once again, those air currents, that kind of stuff.
Yeah, it has a glass shield around it.
Okay.
But I can actually close the side one here, but it won't make any difference. Still says minus 0.027. So that is over a course of, I'm not sure how to zoom in here, sorry.
Oh, you're good.
It's over a course of 30. This would be 30 data points or about 30 minutes.
Okay. So you zeroed it
Okay,
out, and now we're at 40 milligrams in subtracted weight.
It's lost 40 milligrams in half an
Right.
hour. And that
Damn.
was room temperature water.
Okay.
So
Wow.
what you want to do, if anybody wants to if anybody wants to do this experiment, what you got to do is you just take a container that you can put a lid on very tightly so nothing gets out, and all you do is you just pour water into it, as much or as little as you want, right? And you put the lid on. You set it on your scale or on your balance. You can do this on the mechanical scale too. It doesn't matter. It'll do the same thing.
Mm-hmm.
Put it on the balance. Pair it to 0. And then just let it sit. Come back and you can collect the data with any way you want, like with the camera, with the video. This thing here automatically outputs it every minute.
Okay.
Which is pretty nice.
So you're using water in this case. Have you used any other mediums, any other liquids or anything like that? Is there any difference in terms of if we were to use, I mean, I want to think about maybe some liquid metals or something, like oil, for example?
Well, the reason why I believe water works so well is because
Mm-hmm.
it has a very high heat capacity. So
Okay.
water, you can't really beat water in terms of its ability to soak up heat, which is energy.
Mm.
So when the water is first poured into a container, what happens is right above it, everybody knows this, there's a layer of humidity, right? A layer of vapor starts to form. And the longer it sits, the thicker that layer becomes. So the more humidity, in other words, the more water vapor there is right above the surface.
Mm-hmm.
And what that is energy is being absorbed into this blanket right above the water. And quite a bit of energy, actually. I think water vapor is something like 1.9 kilojoules per kilogram Kelvin or something. So it stores quite a bit of thermal energy. So what happens in space, now this gets into the theory as I understand it right now. If you compare what happens in the space just above the water to the space just below the water, where there's just ordinary atmospheric air here, there's far more energy just above the surface of the
Oh, I
water.
see.
And the water will have a center of mass, right? Like if
Yep.
you imagine a plane or a slice going through right in the center of the water. Because of the unequal or asymmetric distribution of energy in space now, that center of mass is going to be slightly shifted.
Okay.
So
Yep.
it's kind of like it'll want to move upwards. It'll want to move towards that layer or volume where there is just more energy.
Right. I see.
So if you were to use other liquids, you would see something happen, and I think it would have to do with the amount of energy. I believe it comes down to the asymmetry of energy. So
The gradient
some
of the
liquid,
energy.
yeah, some liquids, some
Okay.
materials can just hold more energy, right? In space.
I wonder what the best liquid for holding energy would be, and I'd be curious if we could try something like that in the future.
Water,
That'd be pretty interesting. Is that one of the top ones for in
water
terms
is
of
pretty
liquids?
much, yeah. Like if you look it up, it's over 4 kilojoules,
Okay.
kilogram Kelvin. So every degree Kelvin it changes, it's another 4 kilojoules of energy per kilogram.
Right. I see.
Um, yeah. So
So you mentioned that there was an exponential decrease. So we start out at T
right.
zero, and then pretty quickly we drop that, and then slowly that kind of flattens out. Are there any ideas about why we would see that particular type of graph?
Well, I think it's the way, like if you look at if you were to graph out how when you have a temperature difference, something hot, something cold, right? So if you were to graph out how much energy passes from the hot to the cold, like the rate at which it does that, it would follow an exponential,
Okay.
right? It's not a linear. If you were to graph it out, it's not a linear process. It's non-linear because it depends on the temperature difference. So when these layers of vapor expand or form, at first it happens quickly, and then it starts to slow down and reaches a point of equilibrium.
Okay.
So if I leave this for long enough here, it'll stop changing, and it'll just have a new equilibrium point in its weight.
Gotcha.
Now the
So
interesting
never.
thing,
Yeah.
if
Go
I
ahead.
were to change that, if I wanted to change that now, right? Like this is a passive process. It just happens. I can't do anything to that, right?
Right.
But supposing I wanted to change it, I wanted to make it a little bit heavier or a little bit lighter. What do you think I would do?
Maybe just introduce a different temperature to the system. So cool it down, that kind of thing.
Right. Exactly.
Have you ever tried freezing the bottle entirely, seeing what happens then?
I've tried ice,
Yeah,
putting ice cubes in a
because you're
container
gonna
in a
get
Ziploc bag.
you
You
have some
seal it up.
sublimation. You're gonna get a substantial gradient if you have ice and then the vapor that's starting to sublimate off of that.
Yeah. So what happens is the ice absorbs energy from the environment,
Right.
turns into liquid, and
Yep.
then the liquid again forms that vapor layer just above the surface, and so you get the same thing. So ultimately you get a weight loss effect.
Wow.
Yeah, I mean this is the thing, right? It's like I said in our previous call. It's like anti gravity is like literally under our nose. Every time you breathe out on a cold day, you're going to see your vapor is going to go up
Yep.
because it's got more energy than the surroundings, and it wants to rise. Now, if you do the opposite, you cool it down, it's going to become, of course, it'll become more dense, but it will begin to fall.
Right.
So this is where the conversation usually ends with people who are scientifically trained, in engineering or whatever. They'll just say, "Oh well, the density decreases or the density increases." which is true, and it does do that. But what they don't recognize is that the weight will also
Right.
follow,
Density
right?
doesn't necessarily
Change.
map directly to weight. You can have the same material and have two different densities. It's just going to take up a different space. But the weight, that's the
Yeah.
thing.
So like with a
Hmm.
hot air balloon, you get lift due to buoyancy, but you also get this other principle too, this
Right. This gradient.
gravitational modification principle. And this is the thing that's people just can't see the forest for the trees. It's like, no, that's just buoyancy. There's nothing else
Right.
there. You know, I mean, well, there is, there is,
Yeah, we all have
because
our own biases that we look through this with, and anybody that's been steeped in academia is going to have a certain set of assumptions going in.
right, and I did too, because I took a few courses in physics and
Right.
fluid dynamics, and so I mean, they never taught us that if you change the temperature of a substance, it's also going to change its weight.
So it
So,
requires energy to change the temperature in this case, right?
right,
And what we're seeing is admittedly a pretty small change in the weight of the material or the object that we're measuring here, but we want to obviously take this to a point where we can, use this for spaceships. So, do you have any thoughts? Because a lot of the times when people talk about anti-gravity and things like that, you'd think about the Alcubierre warp drive or something where the energy requirement just to achieve something like this is so
yeah,
exponential. It's like the solar system or the galaxy's worth of energy. So, how could
yeah.
does this map at all? Like, what kind of energy, if we were to just have the energy of the sun, could we get this bottle to fly off into space? What are your thoughts in terms of how we extrapolate this down the road?
Good question, and that's where the money is.
Hmm.
Like, this is just an interesting scientific curiosity at this point.
Right.
Um, but I mean, this is where the conversation gets into metamaterials and how much energy can you store in the surface of the material and you know and in a gas. And so the way I think about it right now is you need to have a combination of different approaches. Like obviously, it's impractical to heat something to a point where it just vaporizes and then leaves the Earth's gravitational field, which it
Sure.
will do. If you look at smoke, right? Smoke leaves the Earth's gravitational field, goes up, but it reaches a point where that energy that it was carrying is radiated away. And I think this is where the process to get to space. I think this is where it fails because that energy, like in a hot air balloon, for example, that energy is radiated away. But if we could contain it, instead of letting it escape into space, if we could contain it, we might be able to obtain a higher altitude with these hot air balloons and such, right?
Right.
So
We need a closed system for that. I see.
yeah, so instead of having a material that just is transparent and radiates energy in space, if it's a closed system, if it has a reflective material or something that can contain that energy, I think that there might be a possibility there to obtain much higher altitudes. Um, as to how much, I don't know at this point, but it's something that I intend on, you know, just working on that and figuring out sort of what the limit is.
I see.
Um, but that gets into like high altitude balloons and that sort of thing. So that's sort of a different animal to
Right.
get into.
Th- This is a
With
great proof of
conventional.
concept for what we can do to extrapolate, though. I think we need first principles, groundwork, and this is exactly that, at least in my opinion.
Yeah, so it's a simple idea, and basically you just pump energy into a gas, and we see it all the time, every day. It happens all around us in nature, and you pump energy into it, and then the gas wants to rise. Um, and the question is just how far you can get it to rise. Like
Hmm.
if you could keep the energy in there. And then there could be some possibilities with some other energization methods too. Like there's a lot of buzz around Charles Bueller and Andrew. I don't know if I can say his name. Anyways, the guys at Exodus
Yep.
Propulsion, they've been in the headlines a lot with their capacitor type thruster, and these have
Right.
been around for almost 100 years. But these guys have taken it to another level with their. Uh, I guess what makes the difference is the systematic experimentation they did. Uh, they just did it very systematically, and they did a lot of experiments, whereas a lot of other people just sort of dabbled.
Right.
But my point is a combination of that technique, like high intensity asymmetric electric fields, um, a lot of intense thermal energy, um, and then when that starts actually looking like a plasma, right? Like a hot plasma. So it could be that some of these UAPs they use plasma, right? They have a way of generating hot plasma around
Right.
the surface of the vehicle, and that modifies its gravity, which allows the thing to accelerate. And that's kind of the way I see this phenomenon. It's like this is a very, very weak natural phenomenon, but it's similar in that sense of idea. You create an energy, an asymmetry in energy around it.
Like a wave and a surfer who's riding that wave, basically. The B-2 stealth bomber
Right.
is rumored to use the similar technology where they charge the back with a negative, the front positive. We have that gradient. That kind of goes into the Byfield-Brown effect, and now you start to see that this plane can fly at
Right.
altitudes that don't really seem to support its mass.
It's energy, right? It's all energy, right? Like if you let's look at the equation for the energy stored in a capacitor. It's 1/2 dV squared. So you got the capacitance, the voltage. The higher the potential difference, you get an increase in energy
Right.
storage in the capacitor. And then when you have a gradient, like where you have different layers of dielectrics across the capacitor, then you have these gradients. So you have these changes in permittivity, which is a change in energy density. So I think that's the key here, which is becoming clear to me. Whereas a few years ago it was sort of a mystery. Um, so the more pieces of the puzzle we can see, we can gather from here and there and put it together. And to me, it's starting to look like it's just asymmetry in energy distribution.
Okay. That's really interesting to think about because we know that kind of, in a little bit more of an esoteric sense, like everything is energy, mass, matter, really all of that is just a different kind of representation of energy in a way. So it makes me start to think about, okay, can we figure out how to actually take matter, not just energy, and start to potentially create gradients in that type of way? I don't know if I'm thinking down the right path at all, but just something that came to my mind.
Yeah. So the gradient in space, because um, I think what we're all sort of trained to believe is that space has this fixed, everything is fixed, the speed of light is fixed, these constants, they never change. And I just don't think that's true. I think uh,
Yeah.
I think we've been lied to for a long time. Um, and we just imagine that space is something like elastic, right? These constants are not constant, but they're only what they've measured is a result of the parameters that existed at the time they took the measurement.
Exactly.
All the conditions were a certain way when they took the measurement. But if you change the conditions, if you add more heat here, or if you add some charge over here and then take the measurement, it's going to be different.
Right.
So
Take something like big G, speed or acceleration due to gravity. I mean, that is we're taught it's 9.8 meters per second, but really that is a number that's determined because everyone on the planet who does these measurements averages out together what the ultimate number is.
yeah,
So it's different at different parts of the planet and potentially even at different times.
yeah, yeah. And I would argue that you'll find a difference on a sunny day versus at night.
Oh, yeah.
Like you'll see, and I've seen this on here, watching, just watching the charts, the measurements, over the course of a day. It makes a like two hump. So you got like early morning, it gains weight or something, and then in the afternoon it loses, and then at night so it does this cycle.
Right.
And then if it's cloudy, it sort of messes with that.
Yeah, it flattens that
Um,
out, those differences. Or if you're over the ocean, maybe you get a different experience there.
yeah, and
All
I
these kind
saw this. I live right by the ocean, so I saw this phenomenon,
of.
um,
Okay.
and it ties into this other thing, right? I mean, the ocean absorbs boatloads of energy, and it just creates vapor, and the
Yep.
vapor contains a lot of energy, and it changes the metric of space time, I believe, right? That so the gravitational constant is not going to be the same, um, maybe in a dry place as it is by the ocean,
Right.
or on a sunny day versus a cloudy day, because the energy, the local energy, is not the same. So,
Yeah. So the second time we're talking about this now, I'm starting to. This makes it's making a lot more sense in my head exactly what we're talking about and these gradients and everything. Are you aware of anybody else that's talking about this or trying to do this stuff with any amount of funding, or is it all just people like yourself who are doing this on their own time?
with funding,
Yeah, is there anybody that's talking about these kinds of things?
well, by funding, I guess, do you mean people who are full time working on what I'm
Just,
working on, or
yeah, I guess there are a lot of people who are researching fringes of science, and they have um, maybe somebody that's backing them or something like that. As somebody who's been steeped in this for over 15 years, have you heard any whispers about anybody with real like university type laboratory setups being able to try to implement this?
James Woodward, maybe? He was a
Okay.
university guy,
All right.
uh, but I don't think he got any like huge funding.
Okay.
But he was working on his little Mach effect thruster for a long time.
Right on.
And by the way, the Mach effect principle seems to make sense. I think that's an important idea. When you're trying to understand how these things can move around or defy gravity or just move like horizontally,
Hmm.
because Mach effect is this idea. I don't know if you're familiar with it, but
No.
it's this idea that everything is gravitationally connected in the universe. So there's this network of, you know, through the vacuum, everything is connected. So
Like spooky action at a
it,
distance or quantum entanglement type of thing?
maybe something like that, yeah.
Okay.
So, and this is where the gravitational constant governs these interactions between distant masses, and so, and then this comes down to the energy, local energy, refractive index, and modification of space time, right?
Yep.
Um, these have an impact on the local speed of light, and the speed of light is is in the equation for big G,
Right.
gravitational constant. So there's a relationship there. Um, I'm not a physicist, so I can't go into the nitty gritty mathematics about all that. But I've seen it from. I'll just refer to Alex Unzicker, Dr. Unzicker.
Hmm.
He's been a good source for the variable speed of light conversation that I've come across recently. So
Yeah, I've
I
seen
would
somebody
look into
like
that.
Jack Sarfati is talking about varying the speed of light. If you can get that, because in the case of a lot of these equations, c, which is the speed of light's on the bottom of the fraction, so that's going to basically take, if e equals 1 over c, which is obviously not, but that's going to make e really small. So if we can make c really small, then e is going to go up, right? So that's once again
Hmm.
another person talking about this kind of concept.
Hmm.
Hmm.
Yeah, and I think it's something to really keep exploring and working on. But at least for people on our level who are not like graduate physicists and mathematicians, it
Sure.
gives us kind of an intuitive handle, a conceptual framework to work with when we make experiments so that we can predict that something may happen
Right.
or may not, and sort of know why.
So I wanted to kind of take a step back from the experiments for a second and just sort of contextualize what we're saying by just talking briefly about gravity itself, because I think gravity is largely misunderstood. People think of it
Yeah.
as one of the four fundamental forces. We've got the strong, the weak nuclear forces, we've got the electromagnetic and the gravitational forces. But as I've begun to research more, I've learned that it's not necessarily a consensus that gravity is definitely the fourth force and it's actually always a pulling force down towards the earth. So can you
Mhm.
help me understand, how do you view gravity? What exactly is gravity and how does that play into what you're discussing?
Well, I don't know if I can tell you what exactly it is, but
Yeah,
uh,
maybe throw some paint at a wall and see what
again,
sticks.
we're told that it's a pulling force, gravitational pull, right? Um, the things fall, and but there is this other idea that, and I'm kind of trying to hash this out with David Chester,
Yeah,
Dr.
for sure.
Chester, trying to hash this
Yeah.
out with him. These ideas, right? Like uh, I'm just trying to find two nice. I don't want to say ball. I don't want to say balls, but I want to find two nice balls, right? But
Spheres. Some nice
spheres, thank you.
spheres. Yes,
So,
some
anyways,
perfect spheres.
two bodies, two spheres, right? When they're composed of matter, which is subatomic particles, which is believed to be tiny quantum fields, fluctuations in the vacuum.
Little virtual
Uh,
particles popping in and out of existence.
yeah. So there's something very active when we look at something like I don't know, any object, a metal disc. We just see
Yep.
something inert, it doesn't do anything. But on a very deep level, this is a very, very active situation with all the particles inside there and what they do in space. And the very presence of those particles in space alters the properties of space. So, in other words, you can't separate a chunk of matter from and just stick it in empty space and say that matter is not going to have any effect on space because it absolutely does. Their matter is embedded in that space matrix, that framework, and it could be something like a grid. It could be something like a fluid. Like it has all these sort of different characterizations, like something like a gas, the ether. So I think the main idea is that the presence of matter in space or vacuum alters the properties of that vacuum. And some of the most commonly understood properties are the ability of the vacuum to propagate electric flux, magnetic flux, electric fields, magnetic fields, right? Vacuum carries those, propagates them, polarizes. And so when you have two bodies of matter that can see each other and they're in proximity, the condition of the space between them is different than the condition of the space around them on the other side. So it's that
Right.
difference in the properties of the space between the two bodies. Maybe it's like, I think of it more like a pressure difference, which just makes sense. So a pressure difference will cause them to move towards each other.
Like two ships that are at the dock, and if they're close enough, they end up coming together. That's why you have to tie your ships together
Yeah,
or down, right? Because those waves in between the two ships are smaller than the waves that are outside of the two ships, and so those larger
yeah,
waves end up pushing it together.
right. So there's different layers of complexity to this. I can't I can't go into the deep layers that David Chester can, for example, because I'm not a theoretical, I'm not a quantum physicist, but there's more depth to it, to that mathematical description and model of it. But there's this idea of the ether kind of cramming into matter. You know what I
Mm-hmm.
mean? Like consuming ether. It's
It's
almost
like
like
extra
it's
dense ether.
underwater. You're
Yeah.
underwater and there's pressure. The water pressure is all around,
Yep.
right? But you can't measure it because it balances out. But when you disrupt the balance, then you can see the object move through the water if you change the pressure on one side.
Right.
So it's it's an intuitive way to look at it. Uh, but as to whether there is literally something going in, I couldn't really say with any certainty because I don't have the mathematical or experimental data to prove that.
Mm-hmm. Right. Well,
But
that's a really great example, though. I think, what so many people remember about Einstein is this idea of space and time being the same thing, and that being illustrated by, a piece of paper or a trampoline with a bowling ball on it. And so for
yeah,
everybody besides the 1% of the 1% who has the mathematical head for this, that's what we
yeah,
understand about it. And so what you described is part and parcel to that, and for me that makes complete sense, the concept there. And that's the Casimir force too. That's kind of the
yeah,
concept.
yeah. Casimir force. Yeah, I mean, there's all these sort of different little analogies and pictures we can use to try to ex- kind of shed light on. They all fail in and of themselves, but they give us sort of a way to kind of begin to understand. It's like trying to explain the Holy Trinity. Like God is three persons in one,
Right.
and some have said, well, it's kind of like water. You have liquid, you have ice, you have vapor. So it's like it's all water, but you have three different expressions of the same. And it
That's a good one.
sort of works, but again, it falls way short.
Right.
So
Yeah. Well, I hadn't heard that analogy before. I had heard the one where it was mind, soul, or mind, body, and spirit or soul.
yeah,
So, but that one intuitively, I can understand a little bit better, to be honest.
yeah. So yeah, it helps, but it's not. It's not exhaustive.
Sure.
Um, yeah, the other thing too is when talking about changing the properties of space, changing the the permittivity and the permeability. So we see this actually I don't know if you ever played with radios. It might
Hmm.
be a bit before your time. Or,
I was taking them apart, trying to put them back together, mostly unsuccessfully. So yeah.
can't believe I'm saying that, but anyway, um, anyways, I used to have this electronics kit, right? You get these kits. You can make all these different circuits in one. You need so one of them was like a radio circuit where it had a little ferrite coil. I think it was. I can't remember if it was a metal detector circuit or a radio something. But anyways, I remember I put my hand near this coil and I'd hear the change in tone of the speaker, like I'm like, oh, that's weird. Why is it changing just because my hand is near it, right? So RF can be pretty weird, uh, but I think now the way I would look at that is the presence of my hand is changing the refractive index of the space around it. So the properties, like the inductance of the coil, the capacitance of the coil depends on the local permeability and permittivity.
Right.
So when those are altered, even by a little bit, you'll hear a change in the frequency will shift, and you can actually hear that or measure it. So that helps me to kind of understand, what's kind of going on in space is that these two properties are elastic
Yep.
and seem to be what might be a part of what causes us to fall
I
to the
see.
ground. Um,
Wow.
the other thing to think about too, this is sort of another concept out there that I personally haven't fully stitched together with everything else yet, but there is this thing called the Compton frequency, and so
Okay.
it's like I think it was the frequency at which subatomic particles rotate or something, or like the frequency at which a proton will. But these things are they're like clocks. It's like fixed, and by fixed I don't mean it can't be changed, but they exist in space. They kind of like run on their own clock, right?
Hmm.
These quantum
Consistent
states.
intervals between each instance.
So like the way subatomic particles process and do their thing in space.
Okay.
So I think that might have something to do with the idea of time. Uh, and so in a gravity field, some physics people explain it as being like um, there's a gradient, there's a temporal gradient. So time, I think it was time slows down a little bit as you fall in a gravity field. So and it slows down because there's just less energy as you fall. Um, so yeah, temporal gradient, time dilation. That was the phrase I was.
Oh, right.
They
Yeah, for sure.
explain gravity time dilation. So time slows down, I think, and then your
Yeah.
rulers and clocks shrink. So
Yeah, that makes complete sense because we have to adjust our satellites because they're further from the Earth. They actually have time moves faster for them. So we're constantly updating our satellites. Same thing if you start moving really quickly, as many people know, close to the speed of light, time
yeah,
starts to kind of go away. But yeah, I mean, if any of you've seen Interstellar, that's exactly what's occurring when they go next to that
yeah,
huge planet, right?
and
That
it
can,
also is dependent
yeah,
on velocity. Local, it's
right,
dependent on velocity, right? So the
right,
faster something moves, um, its clock slows down, right? To the point of if you
yeah,
could ever achieve the speed of light, time would just freeze and
yep,
stop. So
right. For a photon, everything's happening at once. I heard
yeah,
the
I
idea, the
guess.
concept of um, if you were to be like a tree who lived for 500 years, maybe 1 minute for us would be like one day for a tree or something, and so they would actually see instead of just us as a static, me looking like the way I do. But for a tree, they might, if they were conscious, which they might be, but they would see kind of like every single place that I've been sort of connected, like I'm a long worm kind of a thing. And I thought that was an interesting way of describing. Similarly, if a photon had a consciousness, it would see everything existing in all of its states at the same time.
Yeah, there's still a lot of weirdness with light, and we're trying to figure out this relationship between. I've done some experiments with light. Oh, this is the other thing I was going to touch on as well.
Yes, I wanted to ask you about some of those other ones. You've done laser work, that kind of stuff.
Yeah. Yeah. So what I found is I haven't discovered this, but mainly I came across Louis Rancourt's work a couple years ago on ResearchGate. And one of his experiments, he described using a line laser. And what he would do is shine the line laser like adjacent to a mass on a horizontal balance. So if you're familiar with the Cavendish experiment, we have the two lead weights on the end of the balance. And he's looking for deflection of the horizontal pendulum towards the lead weights, trying to measure gravity. If you were to substitute those lead weights, like the fixed ones, for a laser, or even just an ordinary light bulb, what you'd find is that, and this is what he found too, is that the heavy weights, the movable weights would move toward the laser light or other light source. So the presence of photon energy in the vacuum, which is another way of saying an energy density.
Right, it's kind of like the vapor above the water.
Yeah, or photon gas. That sort of idea, right? Will cause the mass will want to move into it. So it's interesting. It's a simple experiment to do. It's just you got to be patient with it, and just again make sure you don't have air moving around in your lab or your bench or whatever. That's not hard to eliminate, but.
Are there any other noteworthy experiments? Oh, I'm sorry.
Yeah, just got to have a way of measuring the angle of deflection.
Okay.
So the pendulum will do this for a long, long time. It'll just keep doing this. But it'll change, if you have a light source on one side, it'll change its average position towards the light source.
Gotcha.
And if you put the light source in a box, it'll do the same thing.
Oh, wow. Okay. Have you tried that?
I've tried something like it, yeah. I had lights in a big steel, like a cooking pot, like a reflective pot, and I found that masses did move towards. I think it's a little weaker than just having the light shining all around, like even on the surface.
Right.
But if you put it inside the container, it should have some effect as well.
You know what? I just realized I had an interview with Phil Bouchard, and he showed me a video where they did exactly that. They had this pendulum and lights on either side of a stick, and the pendulum began to twist based on following where those lights were. Now I understand why that's happening in theory. Okay. Sorry, I just connected that dot there.
I didn't know Phil was doing that. Okay.
This was an experiment that he showed me as kind of a proof of concept for his paper, right? He's not doing the experiment himself, but he's saying this paper speaks to what this experiment shows.
Okay.
Yeah. But now I understand why that was occurring.
So that's yeah. I mean, that to me, that's another big piece of the puzzle to tie these different observations together, like what I was seeing before I knew about Louis Rancourt and what he did, what he saw,
Right.
and then his claims were also confirmed by another researcher by the name of Libor Newman.
Hmm.
Um, he did a lot of experiments too with this horizontal pendulum and different light sources in tubes. So he charted it out as well and found that the masses move towards light in every case. So
Wow. Yeah, I mean, that actually goes against what I would have thought if I was just looking at this from purely the understanding that I had prior to kind of starting to talk to you about these things. Is I would have thought that,
yeah,
okay, if I have a light source, it's, if anything, it's going to be creating maybe some heating of the air, which is going to make the air want to start moving around more sporadically, maybe creating a pressure force to go the opposite direction. But what we're saying is it's actually being drawn towards the light. So that's pretty unique.
yeah, and even I would go so far as to say I'm just trying to unify like the principle. Uh, Although strictly speaking, I haven't like physically measured every aspect of this, but you can sort of extrapolate the idea and say that uh, any heated object, like a heated material, would have a similar
Yeah.
principle as well, in that it would tend to gravitationally would be enhanced, or it should
Right.
be enhanced if it has more internal energy and vibration, more momentum, right?
Yep. Wow. I got to think about that. That's really fascinating. So you've done a lot of different experiments. I'm going to be linking to the YouTube channel that you have, Fail Forward Research. I want to showcase a lot of that. You know, I want to get people to be, as I wasn't aware that you were doing this up until a couple months ago. Um, what advice would you have for people who want to start their own labs or start doing their own experiments? How did you get started in this, and what were some pitfalls or things that you wish you knew when you started?
Well, seems like when I got started, there wasn't really. I mean, this is like 2018, so uh, when I look back on it now, it's pretty cringy, like what I was doing, and I'm a little on the embarrassed side, actually, looking back on some things I was doing. But there's other things too. With more experience, I look back on now, and I think there was probably something there, and I need to revisit that because at the time, people would just they would just dismiss everything as ion wind or electromagnetic interference or air currents or so. There's no substitute for just experience. I would say just don't be afraid to make mistakes. That's why I named my channel Fail Forward Research because I just um, I'm just trying to communicate this idea that the only way to go forward really is to fail. Like you have to try things, you have to do things, and then you'll make mistakes. And then the idea is that you learn from those mistakes and you get a little bit better each time. And then so
Right.
you just have to embrace failure, right? In whenever we're trying to do something new or something that we don't know much about, it's just like at the time of this recording, you're a new podcaster,
Right.
so you've probably made a few mistakes and you're probably like learning.
Yeah.
So, and for me, it's the same thing. It's like I'm learning and failing and making mistakes. So maybe I'm wrong on a few things. You know, maybe I'll look back in a few years and say, "Oh my God, oh, I was wrong the whole time." And I there's this one thing I didn't C, you're check.
Right.
So there's always that boogeyman that's sort of like hiding in the closet where like someone's gonna find you out, man. Like someday they're gonna find a problem in your experiment, and they're gonna expose you being a fraud,
Crucified. Yeah, exactly.
right? And then it's like
Yeah.
the guy's right, right? What if he's right? And then I have to retract everything I've been saying for the last 5 years. But
I'd still rather be the guy that's shooting for the moon, landing in the stars, than not even leaving the planet. So,
exactly, right?
yeah.
We can't play everything safe. We have to step out and make a fool of ourselves.
Right. Otherwise, you're
Um,
not living.
that's right. So that's why we're out here pioneering, I guess, making fools of ourselves, and maybe one day, well, the end will justify the means, and I don't know.
Yeah. We all end up at the same place at the end of our lives anyways, so why not go for it?
Why not? So what I'd recommend is, just don't be afraid to make mistakes. Um, you learn the best teacher is experience. Um, Probably want to get. I'd recommend reading up on some of those published experiments that I've mentioned.
Yep.
They're pretty well described. I think. I mean, I don't want to recommend playing with the TT Brown high voltage asymmetric capacitors because there's it's dangerous.
Talk to
So
your doctor. Yeah.
you don't
Talk
know
to your
what you're
doctor
doing
first.
with high voltage. You'll if you kill yourself, that's it's not on us.
Right. Yeah.
So
This is not medical
I wouldn't
advice.
encourage anybody to play with 40,000 volts. I don't encourage anybody to do that. But
Yeah.
as far as the science of physics goes, there is something there. That's why I like this stuff with light and water, because you can't hurt yourself, right?
Yeah.
Just don't shine lasers in your eyes. Like you got to protect your eyes when you use lasers because they can damage your eyes. So just be aware of that.
Yep.
And bright lights. But you know, and then you'll need a sensitive. You should get a sensitive scale or balance.
Okay.
Good to like the more sig figs you can get, the better.
Yeah.
The more decimal places, the better. But you're going to pay more. But you'll need to see probably to see anything happen, tenths of a gram,
Okay.
kind of minimum.
Right. Yeah, it looks like
So
you had
ten-
you had four decimals on yours. I
Like
think.
here, you can see this. This is now reading about minus 0.056, so about 50 milligrams.
Right. Damn.
That's now like 85 minutes.
Yep. Yeah, we've been
Do
out
you
this
see
about
how
an
it's
hour.
leveling off now?
Right.
It's approaching equilibrium.
Hmm.
I really want to zoom in here. I'm sorry I can't.
I mean, it's
Anyway.
taken up a good quarter of the screen, so and I'm zoomed in a little bit. Maybe I'll zoom in too in the editing as well. That'd probably be good. We got a
Yeah,
nice
you can do that.
high quality video. Sweet. Okay. And so
So, is there anything
I
else you
want
wanted to ask about, like the DNP or the nuclear orientation?
yeah.
You were asking me about Wallace patents a while ago.
Yeah, so I mean, I was researching that because I found some descriptions of the alien reproduction vehicle, or the ARV, and how, I was trying to kind of get to the bottom of how one might build one, how we could build an ARV. And I was looking at Byfield Brown and other things, and I stumbled across this work from Henry William Wallace, who we spoke about previously, and he was essentially rotating particular materials at high speeds, like 20,000 RPM, using air jets, and he was actually seeing weight reduction. Is that correct? Is there anything I'm missing there?
I don't think he saw weight reduction. I know he talked
Oh,
about it in his
excuse me.
patent.
Yeah. Was it the kinematic force that he determined,
The
that he
kinematic
discovered?
field, the kinematic field. So
That's right.
basically, what the kinematic field was is it's like an electric current, similar idea. Like again, we're using analogs to electricity, where you have an electric current, which is the flow of charges down a conductor, and then you have a magnetic field that wraps around the conductor. So the kinematic field would be this field that wraps itself around moving mass. So if you had, say, you had water flowing down a garden hose, well, there'd be a kinematic field around the hose.
Just like the magnetic
And in the
field.
case, yeah, and in the case of the rotating the brass, he talks about the brass discs he was rotating.
Yeah.
Well, that would be like you're rotating mass. So you'd have a kinematic field which would be orthogonal to the surface. And that
Yep.
kinematic field would align, tend to cause the nuclei in the copper atoms in the brass.
Right, because brass is
So
60% copper, I think. Something
yeah,
like that. Yeah.
so it would cause the atomic nuclei to align with that
Right.
kinematic field. So you get this polarization of atomic nuclei in the brass. And so his reasoning was, okay, so this is a new type of field which is dependent on moving mass, not moving charge.
Mm-hmm.
Um, and he had a pretty impressive way of measuring that. Like I think it basically was a temperature device on the other end of this brass. It was like a transformer core, except instead of being made out of steel, it was made out of brass. Because the kinematic field would propagate through the brass, given that had these copper atoms. So then he'd measure this very small temperature change on the other end in this special detector. And the patent shows a bit of data that confirms that. So, his other patent too, this is interesting. He describes a device that will cause refrigeration,
Oh,
kind of
I didn't
like
know about that.
a magnetocaloric refrigerator, which is basically just you take a strong magnet and you put it near a material like um, the name of it has slipped my mind. I think it starts with a G. Gadolinium.
Hmm.
Gadolinium. And it will cause the polarization of the electrons and stuff, and it will cause the material to change its temperature. Sort of like, refrigerator where you squeeze refrigerant, then the energy has to escape and it gets hot. So you
Right.
squeeze the energy out with the magnetic field. Well, in this case, with the rotating brass, the kinematic field would cause alignment of the nuclear um, spins, which would cause, in a way, it would squeeze the energy out of it, and it would work like a refrigerator.
Right.
And so then it would then soak up heat, so it would cool it down after a while, like it would stop, just like a refrigerator or a magnetocaloric refrigeration.
I gotta look
And
that
I
up.
think in the
That's awesome.
patent, he claims there is a substantial change in temperature actually
Okay.
in his patent. But I haven't measured anything like that.
I'm gonna have to look that
Not
up later. That's cool.
not to say I couldn't, but I didn't do. I never did a really great replication of that.
Right.
Like Because it's not easy to rotate a big brass flywheel at 20 or 30,000 RPM.
No, that becomes a weapon pretty quickly, a projectile.
It's scary.
So, yeah.
Yeah.
Yeah, that was part of, so in
But
connection, in
so just to
connection,
finish off this idea, so
yeah, yeah.
once you create your kinematic field, which is sort of like a magnetic field around a permanent magnet, let's say, or a coil of wire, if you could then oscillate it, rotate it or jerk it or whatever, so you want to change it, then you'd create something like a gravitational field because um, of the relationship between what was that? Sorry, there's one little conceptual thing I'm missing. I forget. But there's a connection between moving mass and gravity.
Like a gradient of
Um,
some sort, maybe.
I think it's like it's the Maxwell's equations. Like you have a moving a changing magnetic field will produce a changing electric field. So a
Hmm.
changing kinematic field will produce a changing or,
Gravitational.
um, gravitational field,
I
which is
see.
like analogous to an electric field, right?
Right.
In electricity.
What's cool about that is we see that the electromagnetic equations map really similarly to the gravitational equations. You have the difference in mass over r squared, or you have the difference in charge over the distance between the two charges squared.
Yeah,
So there's all these weird parallels that I think we're just starting to kind of unlock the keys to.
yeah, yeah, and then it's all gonna kind of come together.
It better soon. Has anybody, in your opinion, mastered this already? Have any factions of humanity? Are there any groups, whether it be in the government or private sector, that might have already figured out this technology 50, 100 years ago and are already using it? Is that what some of these UFOs could be?
Well, I don't know. I can't prove if this is true or not, but I read in Nick Cook's book, The Hunt for Zero Point. He talks a lot about the Nazis, and he talks a lot about the SS and their secret
Mm,
experiments with one of them was the Die Glock. Basically, that consisted of, I think it was two big barrels of really heavy
Mercury.
cylinders of liquid metal that
Yeah.
was rotated,
Counter rotated, right?
and that was said to produce some kind of bizarre effects. And then you have the the lore about the Vimanas and the Mercury vortex
Mm,
engines. Basically, if you circulate mercury, you create a vortex.
yep.
Um, but I don't know of anybody who's actually done that in a way that I would say, oh yeah, this is a gravity modification experiment. I haven't, except for Phil Bouchard. He was rotating liquid gallium, and it looked
Yeah.
like he got some result with that.
Right.
But I'm not sure. This was a year or two ago. I don't know what came of that. Um, yeah, there's little bits here and there that I can think of, but I don't know how far or how advanced it goes. You just hear something and then you don't hear anything more about it forever,
Yeah.
and it's just like that's where it stops.
Right.
Like apparently, Podplanoff, that rotating superconductor. If you rotate it faster and faster and faster, of course the effect gets greater. But that was not documented in the public domain.
Mm,
Um, actually, okay, well, in the same book I mentioned, there's a
Yep.
conversation that happened. Um,
That's the book that got me
oops,
into this. I,
oops, did I just leak something I shouldn't have leaked?
yeah, no, that was the book
I,
that I
I
realized. Yeah.
yeah, it's good. It's interesting. Victor Schauberger, he's an interesting guy. Apparently, his repulsine machine did some interesting stuff. With he was into making vortexes with air and water. By interesting stuff, I think one of his machines was said to fly or levitated or
Okay.
um, it's a little bit vague at the moment. I don't know
Yeah.
for sure.
This whole area is riddled with vague stories sometimes, but that's just part of the game, I think.
Oh, here's another one. Here's another one. This is probably before, before your time, but in the late 1990s, there was a guy named David Hamill who he lived in near Vancouver, and he bit of an odd kind of guy, and there's a lot of weirdness with his story. You know, where he claims he was visited by these beings, and they showed him inside this
Right.
spacecraft, and what he saw was these cones, these metal cones that were, I guess, wobbling, and they taught him how this propulsion system worked, and
Okay.
so um, he ended up developing this few of these types of cone-based machines that were said to lift off the ground and fly, and then they were confiscated. So this is where the like, I guess people, whatever, men in black came across the border and confiscated this stuff.
Right.
I don't know.
It's hard to say.
But anyway,
Yeah.
these cones would wobble in these magnetic fields, and they would sort of develop this energy over time, and it would just the system would self excite
Right.
to where it would eventually lift off the ground. I don't know if anybody's ever reproduced that. I know there was some there were some pictures on the internet, and I mean like old internet, you know, where experimenters would try to build these things, the cones and the magnets around them. Um, yeah, there's a book called The Granite Man and the Butterfly, I think it is,
Okay.
and I met the author, and but I don't know. I don't know if there's really like if there's really anything clear to go on there. Like there's sort of these ideas and these stories that kind of sort of make sense. It's like the Graviflyer from 25 years ago.
Right. I see.
Uh, I don't know if it's anything that I don't know if it's reproducible.
Right. There's a lot out there, and then I'm of the opinion that if 1% of it's true, then we've got a lot of work to do. We got some pretty cool discoveries to find, and so I'm just trying to
Yeah,
sift through that to find the wheat there, and try to
yeah.
try to get other people into that too. Thank you
Well,
for
I
sharing
hope to at
those.
least
Yeah.
given something that's sort of real. This is real science, real concrete tonight. It's
Well,
not
that's the
spectacular, but at least it's real. You
everything
know.
we've seen. You listening to this right now, you can go home and try this yourself. Like, if you don't believe what you've seen, go take a look, put your own water bottle on a scale and see what happens. And that's what's awesome. Like, we need people who are willing to come out and actually put their face and their name to something and say, hey, I'm trying something. I don't know what's happening necessarily, but I think it's pretty cool, and I think you would too. Let's all figure this out together. There are too many people I know that don't want to speak, or excuse me, that don't want to give the secret sauce away. And, this is a team effort for team humanity, right? At least that's where I'm coming from.
Yeah, and I know there's forces out there that just want to shut everything down, and they want us to live in, you know 15-minute cities with no rights and no freedoms, and
Yes.
restricted this and restricted that, and they want us to eat bugs, and they want us to,
No
like,
possessions. Yeah, and you'll be happy.
can you imagine? Can you imagine being able to strap something on your back and then fly into the mountains?
Yeah,
Just no highways, no roads, no, just go, right?
and that was the dream that we were promised. This is 2025 almost, and we're still using the
2024.
same airplane concepts that we used when we started with airplanes from 1902.
And they still don't really know what causes aerodynamic lift. Still
Right.
not 100% settled science, because there's two camps about this. Like, there's this argument and there's this argument, and the two
Right.
sides can't.
Can't agree.
There's a missing component, is what I'm saying. And I think I know what that missing component is, although I can't explain it in a very precise way right now. Right now, but hopefully soon.
All right. Once you get that wrapped, let's get you on here, and I want to hear it. Is there anything
But
else? Yeah.
I'll explain it as far as this.
Okay. A teaser.
There's something with varying air pressure, very quickly.
Yeah. As we're
So
cutting through the air. Okay.
yeah, if you look at how air flows over an aerofoil, right? There's a very sudden change in
Change in
pressure and
densities.
stuff.
Yep.
Change in densities and air density. Yeah, and I believe there's something to that gravitationally. There's a component there,
I see.
but
Interesting.
I can't precisely define it yet.
Yeah, I got to think about that a little bit. Right on, man. Wayne, this has been amazing. Thank you for taking the time out of your day, not just today, but last week, to sit down and talk with me. I wanted just to wrap up my final question here, just by asking you, what is the main thing that you want people to take away from our conversation today? And then how can people find out more about you?
I guess the main thing is just believe that it's possible, and keep an open mind, and don't stop trying. And I think it's a very important thing. Many of us need more than ever these days is the skill of critical thinking. That we have to be able to look at a variety of sources of information and be able to sort through that information and make not biased judgments. And this goes for science, this goes for politics, this goes for religion. We just have to be able to take in multiple data points and perspectives, and weigh them, and just keep an open mind.
Right.
Um, and that's hard for me to say, because I was brought up as a Christian, and we're sort of known as being sort of closed-minded and narrow and all that. So, but there's so many ways of looking at things, and the universe is a big, wonderful place, and I believe it's beautiful, and we're all created with beautiful purpose, and I just want to help create that better destiny, that better future for us. So
What else are we
yeah,
doing if not that? What's the point if we're not striving for that? That's You're exactly right.
yeah. So we got to keep building and keep creating, right? Like, um, yeah. I mean, just like the creator, I think just keep. And I think that's one of our great weapons against those who want to put us in a box. These psychopaths that want to run the world and put everybody in a box and
Yeah.
divide us and make us hate each other for all these. Anyway, I'm getting too
It's true, man. People need hope right now.
philosophical. I'll
People
stop there. But
we all need hope, and then for me, just speaking for myself, these kinds of things give me hope. And that's what brings me back. So, thank you so much. You have Fail Forward Research YouTube channel, which I'm going to link here in the description of this video. Is there anything else, any other social medias or anything that you want to make sure people are aware of?
the rest of it is in development.
Okay.
I have. I'm trying to get a couple of websites out. Um, one would be failforwardresearch.com. I've got the URL, but I haven't built the website yet. So I'm working on it. I'm working on another one. I haven't publicly said anything yet about it, but I do have the URL. So I
Cool.
think what I'll do is when I'm ready, I'll just make an announcement on my channel
Sweet.
at some point. Check out my website or something like that.
Yeah, man.
I'm also on LinkedIn, just under my name, Wayne Ojala, and Twitter, X, just Wayne FFR, just Wayne Ojala FFR. But anyways, yeah,
Sweet.
that's where I'm at for now.
Right on, man. I'm gonna go ahead and I need to give you a Twitter follow. I didn't realize that you were on there. Sweet. Good to know. Okay, cool. Well, I'm gonna wrap this
Oh,
up
I'm
then. I'll
gonna
start.
just one more little plug. I just want to
Yeah.
give a little plug to Brian Kelly.
Mm-hmm.
Brian Kelly's also on Twitter, and that's why I was reminded of him. But we've had a few conversations, and he's been when it comes to this stuff about anti gravity and this thing about buoyancy and how it's not buoyancy and all this. So he talks about pumped light and all this, and so there's been a lot of things that we have independently arrived at, like conclusions, and so we've been able to come together pretty well with these ideas and experiments. So
That's valuable. Having another person who realizes the same thing kind of confirms what
yeah,
you've already thought. Yeah.
yeah. So he's promoted some of my videos too on light and gravity,
All right.
and so I appreciate that. And so I'm just going to give him the little plug back there too. He's got his own YouTube channel as well, Brian Kelly.
Awesome. I'll put that in the description as well. I want to get as many eyes on this as possible. Let's
And
see.
shout out to Exotic Propulsion,
Yeah.
aka
Alien scientist. Eight.
Jeremiah Pop.
All
Yeah,
propulsion.
alien scientist and Falcon Space Mark there, and the names go on and on. But
Yeah.
yeah,
Let's get them all on the show.
we're-
We want to have a big party. Let's do it. That's awesome, man.
yeah,
Thank you so much. This has been
yeah,
huge. I've learned so
yeah.
much in the last 90 minutes that I've got to sift through things for probably a couple weeks.
I'm sorry. I'm
Nah,
sorry
you're
about that.
keeping me busy. That's great. All right, I'm gonna go ahead and close it out. I'm just gonna ask you a couple questions when I stop the recording, though. So thanks so
For
much.
sure. Thanks. It's been fun. Thank you.